Hi, and thank you so much for coming out to my talk. We don't have a ton of time, so let's just go ahead and get started. Uh, this is my talk. Microservices are over. Long live the monolith. A not very serious talk by Nocnica. Okay, who am I to be talking about this? My name is Nocnica Fee. I am a dev advocate specializing in serverless and containers. I work with cloud engineering tools almost exclusively. And yeah, I pitched this talk to, and I'm super excited to be able to give it. You can find me on Twitter at serverless underscore mom. You can find me on Twitch and on TikTok and every place else at serverless mom. And yeah, let's dive into it. So let's start with some quick definitions. What are microservices, right? With microservices, we have multiple components, right? With no one entitled to, expected to deploy and manage it all, right? A simple request, so a user making a mobile request or making a request from a browser is going to be passed through a UI, which will itself have multiple requests passed into multiple other components. And no one, there'll be some kind of API agreement between all of them. So we won't expect that that any one of them has a complete map of how the others work or what they do exactly. It will just have this API, which it expects to be fulfilled correctly with those other services. Okay, so what is a monolithic service? I didn't do a diagram here because the monolith is supposed to be simpler from a diagrammatic standpoint. We have a single large code base. It has discrete and controlled ingress and egress. So rather than multiple requests passing around, you have a rather straightforward point of entry, or your points of entry are exactly well mapped. Many people are authorized to control the whole thing, but no one person can understand the whole thing. And I think that distinction is pretty key. That you probably have a lot of people who are authorized to deploy to that code base, but you don't realistically expect that one person has a perfect understanding of that code base. Maybe a few engineers who've been there for a super long time do, and maybe that's part of our story as well. Okay, so first of all, let's talk about the benefits of monoliths and monolithic structures. So the first and really critical is that it's very easy to get started. So when we build a monolithic set, it's very much like this building block set that we're able to have all the components we need, usually in a single resource. So we're able to do something like, Rails new and say, hey, we want a new web server. It's going to stand up a database controller, queuing, caching service, every other component that we need, not a service, but as just a component of a single large application. That makes things launch quite a bit faster. If it's critical to you to see these things, you get a much faster launch this way. Because you're standing up only a single service and you're not having to stand up a whole network of components, it will launch quite a bit faster with a monolithic architecture. I don't think anybody really can disagree with that. I think if someone says, hey, I want a big distributed system to build for a weekend hackathon, they're going to know that that's going to be quite a bit more onerous than a monolithic code base. So what happens when that big monolith that was so easy to launch starts to get overloaded with requests? Well, here's the good news. It's very simple to clone that entire code base. Now that does add the complexity of you having to add a load balancer to balance out requests between your two clones, but the clone is relatively straightforward. If you have a complete clone of your code base, you know that all the components that it needs are there. And you're not having to worry that some little piece of that web of components was not correctly cloned over. So it's again relatively simple to create a clone of that piece. By the way, this and many other images are drawn from Wikimedia Commons. There are credits on the slides, and I will make the slides available after this talk. Okay. So this last one is a little more subtle, but definitely worth noting, is the ability to grab data from anywhere. So this is a piece that I think deserves a little bit more attention. So when we talk about the advantages of a microservice system, we say, oh, it's so great because there's this API between all these components. And it is good that there's an API, and there's a lot of reasons why this is an advantage for certain organizations and certain design needs. But when you're working in a monolith, especially early on, one of the pieces that can feel really liberating is that you can sort of grab data from anywhere on the stack. And so when you have things like, oh, I've loaded this user's favorite songs, or I'm being asked to load their favorite songs, wouldn't it be nice if I could get their address from the billing service, because I know people in Tallahassee love this kind of music. Well, that's the kind of data that you can easily get, and you don't have to wrestle with an API like sort of standing in between you and the thing that you're looking for. So the ability to grab data from anywhere, it's not an insignificant benefit. So let's talk about the drawbacks of microservices, or the reason that microservices may be on the outs. Now, for the benefits of a monolithic architecture, I just kind of post an image and set a thing and sort of ask that you accept that this logic made sense. Since microservices are absolutely the in-fashion way to build things, if you look for microservices, they're going to talk about migrating to microservices. If you search for monolithic code, they're going to talk about let's tell you how to migrate away from monolithic code. So they're much more standard. So I think we need to present some evidence if we're going to say, hey, I want to show you how to move away from microservices. So these are direct quotes from people writing that software, people who have some relative experience. Testing a microservices application is much more complex than in the case of a monolithic web application. For a similar test for a service, you would need to launch that service and any services that it depends upon, or at least stub them out. This is Anton Karenko. Okay. All of these slides are both direct quotations and are big blocks of text. So I'm sorry, it's a lot of text. So, here's a cool picture of a bird to look at in between. So yeah, testing microservices application is quite a bit more complex. We can say that, oh, well, no one understands that monolith completely, but the fact is that we have a system that is discrete that we can test. We can stand up, like I say, cloning is easier, so we can set up a clone of it in a test environment. We can simulate things with it. We can run things like Chaos Monkey on it, and all of that is easier with a monolithic architecture. And in fact, most of the large microservice systems that you see are frankly running just unit tests on those individual components and aren't able to test end-to-end as effectively. So each microservice has its own API, which apps rely on to be consistent. While you can easily make changes to a microservice without impacting the external systems interacting with it, if you change the API, the interface, any application using that microservice will be affected if the change is not backward compatible. So one of the really proposed benefits of microservices is definitely the idea that it's supposed to allow you to launch features faster. That may be true in your instance, but I think that it's worth noting that you are very much limited by this API agreement. That you have to absolutely fulfill that agreement all the time, and any attempt to evolve or alter that is going to be met with some resistance. Okay, moving on to our next one. Measuring and monitoring the overall application performance is another difficult task because services run and handle requests in isolation. So trying to say, how is the whole system doing, is a really serious one. I saw some stats recently looking at the state of observability or these monitoring questions in modern IT. A bunch of teams are using 10 or more tools to monitor their application, right? And obviously, if you're clicking between 10 different tabs to know how your application is doing, you struggle. And when we talk about small teams, maintaining single components of the service, great, but you do face the fact that is going to lead to a certain amount of fragmentation. Okay, so this is next is part 3, and I'm going to ask the question, I'm going to make the case to you that you already have a monolith. Okay, architecture is a struggle. And why is architecture a struggle, right? As we design and control, we limit our ability to create features. And this is not anything, this is only present evidence to claim this, right? The simple fact is that if we say, hey, I've created an architecture that as part of its design automatically limits what engineers are able to do, and that prevents them from doing bad things, and that may well be true that it does prevent them from doing bad things. But the fact remains that it's also going to limit their ability to expand the functionality of the system. And the constant that we see in software systems is change and need for expansion, right? So let's talk about kind of how we got to here and the explanation of why you already have a monolith, right? Initially, the idea with a monolith, right, is we had simple control points of ingress and egress, a large, complicated system, but one that we saw really simple relationships between inputs and outputs. Again, a lot of complexity hidden within that system that takes a great deal of time to understand, but still a straightforward relationship between inputs and outputs. As we saw our monoliths grow, and as we saw the number of requests grow, we started to get into a difficult situation where we're seeing more and more pieces are coming into the system, greater and greater complexity as we move forward. So the idea with a microservice is, let's shrink the amount of code that any one team is responsible for. Let's focus in, let's add to our competency in this one small area. And this is supposed to be the benefit. The reality of microservice architecture, of course, is that this is not an accurate model, right? In fact, we have a complex web of relationships, sometimes working in multiple directions of components that draw information from multiple sources, send it out to multiple sources. And only by understanding that complete map are we able to understand this simple ingress and egress. Now, that complex map of requests is something that we could technically draw a large box around and say, hey, we have this large box around a big honking thing, a lot of complexity that is required to answer one of our questions, right? And, I think that might kind of start to look like a monolith. And I think that the associations of monolith, well, it's just this massive complexity that nobody's able to understand or really comprehend. I think that it's completely reasonable to say, oh, well, that's what we already have when we have this microservice architecture. So one of the things that I really want to focus minds on a little bit here is that those connections are a really key part of this. Now, in some ways, again, they're a huge benefit. If you can document these APIs that exist between your services, then you can limit the ways that they are connected. You actually can understand a lot of the complexity of your system in a way that you really can't do with a monolithic architecture. But those are also big limitations. And any failure in this network of interrelationships will cause your whole system to fail or act in unexpected ways. And a really frequent request that you see when people do automated observability tools that measure things automatically about your system is people will ask, I want to just see a service map because this one microservice, maybe the one that I'm in charge of, I do not know how it's related to other components. And so yes, you're fulfilling your API contract, but your ability to really understand how your pieces connect to others it can be low. So again, we get to that point of very often the sort of when people list 100 benefits to microservices, and these are sort of cons to using a monolith, that very often isn't like you can just zoom out a little bit and you can see, oh well, you have these same problems, you just have them in a different layer of complexity. Okay. So you start to have this really complex web of interrelationships, and the ability to even track like where a request goes when it gets responded to starts to feel like impossible. And so you see products like AWS X-Ray trying to answer this question, trying to say, well, at least for one request for your online shoe store, what happened when someone bought this pair of shoes? Where did the request go? What services were involved? Now, that could be okay, right? A service that goes, a service over here that gives people coupons every time they buy a pair of shoes, it's okay if you didn't really, if you handled this purchase process green to green here, it's okay that you really weren't aware that there was this effect over here in the coupon service. Might be all right. But the fact is that you do get to this point of there being quite a web of complexity. Okay, let's talk about part 4, which is the human factor. And I think that, I used to have a joke that really landed when I was talking about you have to consider the human cost of any design decision of your architecture. And my joke was, this is back in 2019, 2018. I said, now, which CTOs, how many CTOs here are saying that they have trouble hiring engineers, qualified engineers for some modern cloud architecture? And, everybody experiences that. And I said, when's the last time you heard of a CTO saying, oh, I couldn't buy RAM, or I couldn't buy cores, this month? Now, we have a microprocessor shortage right now, so this is less funny of a joke right now. Yes, you actually can face shortages in buying hardware, but the fact is that, having human staff has proved to be a persistent and significant barrier to growth of a cloud system. So I think it's really important to take a little time to consider what these human factors are when we adopt an architecture. So there's this sort of canard about the two-pizza team. And unlike a particular technology being connected to microservices, the two-pizza team really is an important idea with microservices. And one of the advantages is the idea that you want your component that you're responsible for to be managed, developed by a group of engineers that can be fed with two pizzas. This is a pizza place in the Philippines, so like Pizza Hut in the Philippines. These seem like pretty small pizzas, but you get the idea, right? What is that? 8, 10 people, right? It's the max that a team size should be. And I don't disagree with the two pizza team as being like, if you're responsible for features collectively, it's a pretty good idea to limit the number of people who you have to go to for answers, who you have to check in with, to check out code, and to do all these things. And in fact, this little, illustration here, I'm talking about, the complexity that a technical request can go through when passing through your stack, I think is absolutely can be applicable to a group where you have a large monolithic code base, and this is the complexity you face trying to get the answer to a question, right? To say, how does this component work? Who designed it? For what purpose? What is line 23 doing here, right? It can just be very hard to get answers to that, and you can find yourself kind of trapped in this maze. I think that the fact is, though, that to correctly evaluate the reason monoliths fell out of fashion, you have to talk about a fear of a too powerful employee. So the idea with these like little two pizza teams is you have these little groups that are responsible for limited responsibilities within the stack. And that's needs must, right? 8 engineers can only manage so much of the system. In a monolith, you will have a few people, a small number of people who really understand the whole system really well. And they become super valuable. They become these answer givers and trainers and really key people. And, you have to talk about the fact that there is a fear by your management of saying, hey, this person is too powerful. They ran everything. They didn't act right and weren't respectful to people and stuff, but I had to keep them because who else understood the system? And I don't think it's unreasonable to say that the concept of the two-pizza team in specific and the microservice architecture in general is one pioneered over at AWS, which definitely is not the company with the best track record of treating its employees like stars and respecting the value of individual employees. I think that is a group where you will often see, an emphasis on we want to be able to replace you. Now, okay, the other side of this. Sure, you can say, hey, don't be afraid of monoliths because it's okay if you have a few valuable employees, keep them happy, handle it. But, talking about the bus factor is a very real thing. The bus factor, if you haven't heard it, is the maximum number of people that you can have hit by a bus before the minimum number of people you need to get hit by a bus before your technical team really has problems shipping new code, delivering features, what have you. And so, any operations architecture that will fail if one or two people get hit by a bus is not good, right? So, building big complex architecture is saying it's okay because Maria and Dave both understand it and we're good to go. Yeah, that's not a great situation long term. But it is just true. So another kind of factor in this concern is that we may have avoided monoliths because we have a strong desire to start every engineer working today and are no longer willing to wait 6 to 9 months before they can do anything useful. And, for better or for worse, this is the reality, that we really want to start people, say, hey, you're enough of an expert now, we expect you to ship a few features in just the next couple of weeks, and we don't want to wait for you to spin up. Now, I've seen some negative sides to this, for sure. I've seen, a team that's really unwilling to develop junior engineers into experts. And that really affects people's career growth. It really affects someone's ability to expand their network and add new people. And those are kind of serious negative sides to this. But, it's also true that if you stick with a really big complex system, right, this ramp-up time is hard on an organization and the person who's struggling to get up to speed. And that's true as well. That it's great if an org is like, oh, we're willing to invest in you and take time with you and let you get up to speed. But it's tough. It's tough going into work every day and not getting to ship features. Wouldn't it be nice if we were working on a small team that was more together, that had a more limited scope, and so as long as I understand that, then I'm able to get forward. So what are our key takeaways? We got one more slide, then we're out, folks. Thank you so much for sticking with us. So, no single architecture is better for all your design needs. So, there isn't any single model that is perfect. And right now you're hearing microservices as if it sort of just by default is correct. But there really isn't any single design paradigm like that is going to define things well. Like, we don't want to repeat ourselves, right? We say, oh, we want dry, don't repeat yourself as a design concept. That's true. But if you're finding yourself, pasting a little bit of code from one class to another, it doesn't mean you need to stop working that day or you need to find some way around it, right? Repeating yourself is part of the deal. Using a technology does not require you adopt a particular architecture. I didn't actually get as far into this as I wanted to in the slide deck. Because I work with both containers and serverless, a lot of people sort of think those terms are synonymous with microservices. And I would say, especially like serverless computation like AWS Lambda or Google Cloud Functions, people say, oh, well, that's microservices. You just sort of have microservices by default. We can make an absolutely large software package for your AWS Lambda. And in fact, you can chain a couple of them together, and now you have a really big single block of code that is running most of your requests. So, and you don't, yes, you have to define connections between them, but that might not be a proper API. It might just be like, accepts one massive request and sends back some other massive response without any clear contract about what it's supposed to be doing there. So, adopting a particular technology does not mean that you automatically are doing microservices. Using maybe an older framework does not mean that you're necessarily doing a monolith, right? You can absolutely stand up dozens of Rails components, tiny little Rails servers that do little pieces of the job, and you can absolutely use Rails or Java or what have you to build microservices. Any large system is going to be hard to maintain and manage. So any promise that, if you adopt some different architecture, it's going to be, self-documenting, self-correcting, require no maintenance, right? Anybody who's spent time working with Kubernetes knows that automation is doing a lot and achieving great uptimes and great performance for people. It is not disappearing complexity, making things easy, meaning that people can go on 9-month vacations and assume things will go fine, right? So, yeah, any system that's large and big and complex is gonna involve some complexity. When choosing an architecture, consider the human costs. So we just need to take into account what it's going to do to our people to adopt a certain system, And especially in the modern context when it's getting really hard to find good people, where good people are getting paid a lot and seeing a lot of opportunities, it can just really be a question to say, hey, if we adopt this technology, what will be the effect on our developers? How much toil are they going to have to go through? How much hand management? How much are they going to be woken up at night? And in the end, how tempted are they going to be to leave, which will limit our ability to grow? Okay. So, folks, that's been my time. I again am Nocnica. I talk about serverless containers. You can find me on Twitter at serverlessmom, serverless_mom, on Twitch at serverlessmom, and on TikTok at serverlessmom. And also look me up many other places, GitHub, what have you, at serverlessmom. Thank you so much for coming out. I'll be available in the chat to take questions and responses. Feel free to write back to me there. And I hope you have a great conference.